we're going to talk about arithmetic sequences and sums. And the big thing to know is that these are arithmetic. Tomorrow we'll talk about geometric, and there are formulas, I think, on your formula sheet that talk about both of them, and you're allowed to use that formula sheet if you haven't written on it other than your name. But the problem is people always mess up which one's which, arithmetic, geometric, if they make a mistake on these. So the big idea is to remember which one is which, and there are key phrases that will help you. So an arithmetic sequence is one where when you go from one number to the next, you're either adding or subtracting the same thing. So like 1, 3, 5, 7, 9. That's an arithmetic sequence because you're adding 2 each time. The amount that goes in between each of those is called the common difference. Your a sub 1 is your first term in the sequence. And your a sub n is whichever term you're talking about. Like if I want the 7th term, that means I'm looking for a sub 7. So up in the beginning, they have these 2 formulas. I don't really do both of them. I just memorized one because kind of like the law of cosines or anything else, if you know one, you kind of know them all. So I know this one. A sub n is equal to a sub 1 plus parentheses n minus 1 times parentheses d. So that's looking for any particular term in a sequence. The a sub 1 is your first term. Your d is your common difference, like jumping by 2. And n is how many terms are in the sequence. And it's usually best if we just try a few problems. So the first problem, number 1, is asking us to find the common difference. Or in other words, what am I jumping up by each time? And an easy way to do this is just to take the second thing and subtract off the first thing. And you find out your common difference is 3. And they call that D for difference, I guess. In letter B, if I do the same thing, and I take the second number minus the first number, I see that I get negative 4. So my common difference is negative 4. And in the third one, if I take 2/3 minus 1, that's negative 1/3. Or in other words, I'm subtracting off 1/3 each time. My common difference is negative 1/3. Or geometric. So one of the things that's kind of important when you're doing these is to know if you have an arithmetic or geometric sequence. So you should check to see if things are going up or down by the same amount each time, adding or subtracting. So in part 2 here, for A, what I'm going to do is go, hey, when I'm jumping from 3 to 6, I added 3. When I'm jumping from 6 to 7, I added 1. Oh, whoops, already I know. No, this is not an arithmetic sequence because I'm not going up by the same amount each time. Done. In letter B, to go from 1 to negative 4, I subtract off 5. Negative 4 to negative 9, I'm subtracting off 5. Negative 9 to negative 14, subtracting off 5. So the answer is yes. It is an arithmetic sequence. Does anybody know the difference between a sequence and a series?
Multiple sequences.
Gannon?
Is a sequence a set of numbers that depend on each other in a series? Is just a set of assorted numbers?
Nope. Good guess. Sam?
Is the sequence infinite?
Not necessarily. Good guess. Anybody else? Joe?
A sequence will for sure repeat and series won't repeat.
Sorry, not correct. Good try. Gannon?
A sequence is a board game, and series is something the author writes.
Nice. Very clever for a 6-year-old. All right. A sequence is a list separated by commas, like the ones you see below. The series is a list, but it has addition. So the big idea is if you're talking about sequences, commas. If you're talking about series, addition. That's what you need to know. Okay, so this last one, maybe something that might be a little bit challenging, might be the fractional things. So to go from 1 to 1/2, that is a subtraction of 1/2. But to go from 1/2 to 1/3, did I subtract off 1/2?
No.
No.
Definitely.
So I don't even have to know what the fraction is that I subtracted, because if I didn't subtract off 1/2 again, it doesn't matter. So the answer is no. It is not an arithmetic sequence. In number 3, it would be really important to remember the formula that we talked about earlier. So just in case you don't remember, any term I can find with the formula a sub n is equal to a sub 1 plus parentheses n minus 1 times d. I write this formula down all the time when I'm working with arithmetic sequences, when I'm trying to find a term, because it helps me remember what to do. So if I want the 7th term, that means I'm looking for a sub 7, the 7th term. And I know that the common difference is 5. So as I write down the common difference, that goes on the outside, 5. The first term is 9. And what should go in for the n? 7? Because there are 7 terms. So now I have 9 plus 6 times 5, or in other words, 39 is the 7th term. And you could actually, if you wanted to, list these out and figure it out, right? Like the first one is 9, 9, 14, and just keep on going. But if I tell you to find the 7,234th term, have fun with that. In number 4, a little bit more of a general idea. It says find the nth term again. So they tell me a couple of things. They tell me that the 5th term is 19. So that means that a sub 5 equals 19. And they also tell me that a sub 9, because the 9th term is 27. So a sub 9 is 27. So let me show you where those came from. Please stop humming. Now, this is helpful because if I put things into a formula, there are other ways to do this, of course, but I'm just going to show you the algebra way. There's guess and check ways. There's a lot of things going on. So let me show you what I would do algebraically. So using this information from the first thing, what that means is if I was looking for the a sub n term there, I know that I would have the a sub 1 term, right? Time, or plus n minus 1d, because that's my formula. And they tell me that a sub n, which is the, which term did they give me? The 5th one, was 19. And that was equal to the first term, which I don't know. Plus, they told me it was the 5th term times the common difference. So that's information I gathered from the pink information. So I know a lot of things there. I know that I have 19 equals a1 plus 4d. Now this is an equation with 2 variables in it, a1 and 4d. In the purple, if I was doing this algebraically, I know that a sub 9 was 27, and that was equal to my a sub 1, which I still don't know, plus, since that was my 9th term, it would be 9 minus 1 times d. And so if I rewrote that in equation format, simplified, that would be 27 equals a sub 1 plus 8d. And now what you see is you have 2 equations and 2 unknowns. Do you guys see that? So one of the things that would be really easy to do is I could take that pink equation and I can multiply everything in that pink equation by -1 both sides. Changes all the signs. So if I multiply both sides of this equation by negative 1, what I end up with is negative 19 equals negative a sub 1 minus 4d. And I can combine those two equations, and when I combine them, what I see is that I have 27 minus 19, which is 8, and 8d minus 4d, which is 4d. And all that did was tell me that my common difference is 2. So I did all that work to find d is 2, which now I know goes into the formula up here. And the whole goal, in case you weren't aware, from the very beginning, when I read this, is to find the nth term. That means they want you to write down a sub n equals something. So I'm missing another piece. I'm missing the first term. But I can find that now if I want to, because what I could do is I could plug that into any of the equations and find my a sub 1. So for example, let's say I take that d and I shove it back into the pink equation on the far right. 19 equals a1 plus 4d. If I did that, I would have 19 equals a1 plus 4 times 2. Or in other words, I know that the a1 has to be 11, because 11 plus 8 is 19. And that 11 now goes in for my a1. And the whole goal of this problem was to say my a sub n equation is equal to 11 plus n minus 1 times 2. So now, the reason that you wrote down this equation is if they ask you a subsequent question, you could pick any number they want. I want the 23rd term. Okay, put a 23 in for n and you're done. Now, this is not the only way, but I want to show you the algebraic way. Like you could do guess and check and a lot of other methods, but that's the algebraic way. In number 5, we have 2 terms. So I know that a sub 1 is 1 and a sub 2 is 6, or I suppose you could have written it as 1 comma 6, and the sequence keeps on going. You're supposed to find the 9th term. So your goal when you get done is to go, hey, a sub 9 equals, and there's some things that we need to fill in. So I know that when I'm doing these problems, I always need to say, oh, a sub n equals a sub 1 plus parentheses n minus 1 d. So I know my a sub 1. That's the good news. That's just this thing right there. And I know my n. What's my n going to be?
9.
9. So they tell me I want the 9th term, so I know that's my n value. So all I'm really missing is my d, my common difference. And the way you find your d is just figure out how far it took you to go from 1 to 6, which is 5. So now I can go, hey, a sub 9 is going to be my first term, which is 1, plus n, which is 9, minus 1 times 5, which is my common difference. So if you're having trouble visualizing, this is my common difference. So that would be this thing, which is that thing. If I'm looking for my first term, that was this thing, because they told me that was my first term. And so that's here. And then my n was talking about 9th term. So that was my n here, my n here, and my n here, and my n there. So the rest of our problems deal with sums.